Today's lab is motion of a falling object. In this lab, we compare falling object in the real world with a computational graph that includes effects of gravity and drag. For the setup, there is a meter stick here, and we dropped a small ball from the top to the bottom, free fall from the meter stick. During the setup, our ball was not directly above the meter stick. It's actually slightly, it's like 80 centimeters. The ball dropped like 80 centimeters instead of a 4 meter. This lab is over Newton's second law, as well as momentum and velocity update formulas. Those are all used in the computational model to accurately represent the free fall of the object from the meter stick. So in Tracker, we used it to track the ball's movement, and the results are used to create a graph. For the computational model, there are two parts. The first part is gravity only, and you can see here that the ball's mass, gravity, and the velocity update and position update formula are all used in the Glow script to create the computational model and the graph accordingly. Next, we have the computational model with gravity and drag force. We can see that we added the magnitude of the speed squared and also the normalized vector. And in doing all of this with the proportional constant, which here we have it at 0.05 to best match the observed video. So here is the final graph of all three of the previous graphs combined. We have the tracker, the computational model of gravity, and the computational model with the gravity and drag. So we can see that the computational model with gravity and drag were closer matching the tracker one. This is because in real life there is a drag force and a gravity. So the computational model with gravity and drag closer matches the tracker, which is the real life, versus the computational model with gravity only. We can see that although both models are very similar, the one with gravity and drag made the ball slow down more and eventually reach as low as the model with only gravity. So one of the extra questions for this lab was terminal velocity. Neither of my computational models showed any sign of terminal velocity. Terminal velocity is where the drag matches with the gravity, and therefore creating a net force of 0. And none of my computational models have that. Question 2, what if? So if the ball was thrown downwards in the beginning instead of from rest, there would still be no difference because during the actual motion itself, they both have the same amount of forces, the force of gravity and drag. The force that was exerted on the ball at the start is no longer present during the movement. Since terminal velocity is determined by net force equal to 0, the initial force has no effect on this. Because during the traveling time, the initial force has no effect on the net force. That concludes my presentation over Lab 2, motion of a falling object.